For the first time in over 50 years, humans have gone beyond low Earth orbit, and this mission is unlike anything before it. For 53 long years, no one traveled that far into space, not even once. It was the longest pause in human exploration since we first learned how to leave Earth. That changed some few days ago when a rocket carrying 4 astronauts blasted off from Florida, heading straight toward the moon. But Artemis 2 is not just a repeat of Apollo. It's not a copy or a sequel. The astronauts on this mission, Reed Weissman, Victor Glover, Christina Koch, and Jeremy Hansen, are experiencing things that Apollo crews could never have imagined. In fact, some of it would have sounded like pure science fiction back in 1972. So what's different after all these years? Almost everything. Let's start with the spacecraft. During the Apollo missions, 3 astronauts had about 210 cubic feet of space to live in. That's about the size of a large closet. Imagine 3 adults stuck in a closet for up to 2 weeks. That was their reality. Now compare that to Orion. It gives 4 astronauts about 330 cubic feet of space, nearly 60% more room. That's roughly like 2 minivans parked side by side with the seats removed. It's still tight, no doubt about it, but when you're hundreds of thousands of miles away from Earth and haven't stretched your legs in days, that extra space makes a big difference. And it's not just about comfort, it changes what the crew can actually do. For example, Orion has a proper bathroom setup. It includes a system similar to the one used on the International Space Station with a real toilet and, most importantly, privacy. Apollo astronauts had none of that. They had to use plastic bags right in front of each other and then store the waste inside the cabin for the rest of the mission. Many astronauts later said this was one of the worst parts of going to space. The Artemis 2 crew won't have to deal with that, and honestly, that alone is a huge upgrade. Then there's exercise. Apollo astronauts didn't work out in space at all. There wasn't enough room, and NASA accepted the physical weakness that came with short missions. This time, things are different. The Artemis 2 crew will exercise almost every day using a compact device called a flywheel. It's small, about the size of a carry-on bag, but powerful. It works like a resistance system using a cable, letting astronauts do exercises like squats, rowing, and even deadlifts. To put it into perspective, the exercise equipment on the International Space Station is massive, weighing over 4,000 pounds. This small device does a similar job with just a fraction of the size and weight. Apollo astronauts often return to Earth feeling extremely weak. Some could barely stand. But Artemis 2 astronauts will come back after lifting weights in zero gravity on their way to the moon. That idea would have sounded crazy during the Apollo era. The rocket itself has also evolved. Back then, astronauts rode the Saturn V rocket, which produced 7.5 million pounds of thrust. Today's Space Launch System is even more powerful, generating 8.8 million. That's about 17% more. Like Saturn V, it's designed for a single use. While modern rockets from companies like SpaceX can land and be reused, this one is built for one purpose: sending astronauts to the moon in a single launch without needing extra steps like refueling or assembling parts in orbit. But the biggest changes might be in how the spacecraft gets its power. Apollo missions relied on fuel cells and batteries. They produced electricity by combining hydrogen and oxygen, which also created drinking water. It was smart, but limited. Every bit of power came from a supply that kept running out. Orion is different. Once in space, it opens 4 large solar panels that collect energy from the sun. As long as sunlight is available, the spacecraft can keep generating power. This changes how the mission feels for the crew. Apollo astronauts were always aware that their resources were running low. Orion's crew still has to manage essentials like oxygen and water, but their power supply is much more reliable and long-lasting. And here's something surprising. The service module, which handles propulsion and life support, wasn't even built in the United States. This mission isn't just American, it's global. Part of the spacecraft was built in Europe by Airbus Defence and Space and provided by the European Space Agency. Back in the Apollo days, everything was made in the United States from start to finish, but Artemis is different. It's built through teamwork across countries. That's why a Canadian astronaut is part of this mission, thanks to an agreement signed in 2020. European technology is helping keep the crew alive, and what comes next will involve even more countries. Plans include the Lunar Gateway, a small space station that will orbit the moon, built by different nations working together. The days of one country going to the moon alone are over. What we have now is more complex and sometimes slower, but it spreads out the cost, the risks, and the knowledge. Now let's talk about what's inside the spacecraft. The computers on Orion are on a completely different level. They are about 20,000 times faster than the ones used during Apollo. To give you an idea, Apollo's computer had just 72 kilobytes of memory and could handle about 40,000 instructions per second. Even a basic smartphone today is far more powerful. Orion, on the other hand, runs 4 computers at the same time. Each one is far faster than the systems used on the space station and even the space shuttle. The cockpit has also changed completely. Instead of switches and dials, everything is digital: touchscreens, software controls, and live updates. Apollo astronauts had to read gauges and calculate things by hand, often relying on experts back on Earth to guide them. Orion is much smarter. In fact, it can almost fly itself. It already proved that during an earlier mission in 2022, when it completed a full trip to the moon and came back without any crew on board. That's a big deal. During Apollo, astronauts depended heavily on mission control in Houston. Most of the important decisions were made on the ground, but Orion is shifting that balance. The Artemis II crew is actually flying the spacecraft themselves in deep space, testing how it responds when humans take control. They are trying out different steering modes and learning how the vehicle behaves. Apollo astronauts only flew manually during key moments, like landing or docking. They didn't pilot the spacecraft freely in space like this. This change is important for the future. If humans go to Mars one day, communication delays could be as long as 20 minutes. In an emergency, waiting for instructions from Earth wouldn't work. Astronauts will need to rely on themselves, and Orion is designed with that in mind. Communication itself has also taken a big leap forward. Apollo missions used radio waves to talk to Earth. It worked, but it was slow and limited. The sound quality wasn't great, and sending a single photo could take minutes. Orion still has radio as a backup, but it mainly uses something much more advanced: laser communication. This system uses light to send data back to Earth at incredibly high speeds. Just a few days into the mission, it had already sent over 100 gigabytes of data, including clear, high-quality images taken by the crew. For comparison, Apollo missions sent back only a few megabytes in total. Now, astronauts can share detailed images from deep space almost instantly. When Christina Koch looked back at Earth and captured that moment, people on Earth were able to see it within hours. That's something Apollo could never have done. Even the view of the moon feels different. Apollo spacecraft flew very close, about 70 miles above the surface. From there, astronauts could clearly see craters and watch the line between day and night move across the moon. Artemis II won't fly as close to the moon as the Apollo missions did, and that changes everything the crew will see. At its closest point, the spacecraft will still be about 4,000 miles above the moon's surface. That's much farther away than Apollo ever flew. But this distance comes with a special advantage. Instead of seeing just a small part of the moon at a time, the astronauts will see the entire moon all at once, from top to bottom, a full, round view filling their windows. No Apollo astronaut ever experienced that during their closest approach. And that's not the only first. Because of the path this mission is taking and the exact timing of the launch, the crew will witness something no human has ever seen with their own eyes: the Orientale Basin. This is a huge crater on the edge between the near side and the far side of the moon, stretching about 600 miles wide. Spacecraft have taken pictures of it before, and scientists have studied it for years, but no person has ever actually looked at it directly. During Apollo missions, this area was always hidden in darkness or just out of sight. Artemis II changes that. For the first time ever, astronauts have seen it with their own eyes and even taken pictures through the spacecraft windows. That's a big moment. It means humans are now seeing parts of the moon that, until now, only machines had explored. There's another rare event waiting for them too, a very unusual kind of eclipse. From Earth, we're used to seeing the moon block the sun, but in this case, it's the Earth that will block the sun, as seen from the spacecraft. This eclipse will last nearly an hour and will happen shortly after the astronauts see Earth rising in the distance. Nothing like this ever happened during Apollo. It just never lined up that way. This one wasn't even planned. It just happens because of how the spacecraft moves around the moon. Scientists and the crew are treating it as a special bonus. Imagine this. You're floating in deep space, behind the moon, in complete silence. In front of you, Earth appears as a thin blue curve. Slowly, it moves across the sun and blocks its light. It's a view no human has ever experienced before. The astronauts say the sights are already beyond anything they trained for. Seeing Earth from that far away, its full shape, entire continents, even faint lights like the northern lights, is something almost impossible to describe. And the best views are still to come. This mission will also set a new record. The crew will travel farther from Earth than any humans in history. Before now, that record belonged to the Apollo 13 astronauts. They reached that distance by accident, after an explosion forced them to loop around the moon to survive. Artemis 2 went even farther on purpose. It will travel about 4,000 miles beyond that old record. That may seem small compared to the total distance, but it means something important. Apollo 13 went that far because something went wrong. Artemis 2 will do it because everything is going right. The mission will follow what's called a free return path. This means the moon's gravity will naturally guide the spacecraft back to Earth, even without a major engine burn. For Apollo 13, this path was a backup plan used in an emergency. For Artemis 2, it's the main plan from the start. And finally, there's one last challenge waiting at the end of the journey: coming home. When the spacecraft re-enters Earth's atmosphere, it will be moving at around 25,000 miles per hour. That's faster than any humans have ever traveled during re-entry, faster than Apollo, faster than the space shuttle. It's a speed no one has ever survived before, until now. Faster than anything humans have ever experienced, Artemis 2 will slam through Earth's atmosphere at incredible speed. Its heat shield will face temperatures near 5,000 degrees Fahrenheit as superheated plasma swirls around the capsule. For several tense minutes, the crew will be completely cut off. No contact with Houston, no way to intervene, relying entirely on the engineering that protects them. That shield carries its own story. After Artemis 1 returned in 2022, engineers noticed unexpected wear on the ablative material. Parts of it charred and flaked off in ways no model had predicted. The core structure remained intact, and temperatures inside stayed safe, but it raised serious questions. NASA spent years analyzing the shield, convening independent review teams, and debating whether it was ready to carry humans. Some engineers argued for a complete redesign. In the end, NASA Administrator Jared Isaacman reviewed the data and consulted experts before approving it. Artemis 2's shield is largely the same design, with improvements planned for Artemis 3. The astronauts understood the risks and accepted them. Every astronaut ever has made that choice, trusting imperfect engineering and acknowledging that exploration is never without danger. But Artemis 2 also represents something Apollo never did. Victor Glover is the first person of color to travel beyond low Earth orbit. Christina Koch is the first woman. Jeremy Hansen is the first non-American on a deep space mission. Hansen, a Canadian, joined thanks to a 2020 treaty formalizing Canada's role in Artemis. Apollo, by contrast, was all-American, all-white, all-male. Not because NASA explicitly excluded anyone, but because the path to becoming an astronaut at the time was itself exclusive. Artemis 2 doesn't erase that history, but it does show that the first humans to see the moon up close in over 50 years better reflect humanity itself. Inside the cabin, a quieter experiment is underway. The crew is being closely monitored for the biological effects of deep space radiation, more thoroughly than any Apollo mission ever attempted. They wear radiation sensors, have their sleep and heart function tracked, and every movement is analyzed. In low Earth orbit, Earth's magnetic field shields astronauts from most dangerous space radiation. The International Space Station orbits safely below the Van Allen belts. Since Apollo 17, no crewed mission has ventured past those protective layers, until now. Artemis 2 passes through both belts on the way out and back, exposing the astronauts to concentrated cosmic radiation. Apollo crews experienced this too, sometimes seeing flashes of light from particles striking their eyes, but their monitoring was primitive by comparison. The data collected on this mission will inform how humans travel in deep space for decades to come.
Artemis 2 sent 4 people to deep space, the most humans ever outside Earth's protective bubble at one time.
Apollo never sent more than 3. They eat rehydrated meals heated in a device the size of a briefcase. They sleep in bags attached to the walls of a cabin barely larger than a walk-in closet. They exercise on the 30-pound resistance device. They've already glimpsed parts of the moon no one alive has ever seen. And they're doing all this in a spacecraft that, at its core, is still a capsule. Bigger than Apollo, smarter than Apollo, better equipped and more connected, but still a capsule. A metal shell with a heat shield on the bottom and parachutes on top, designed to keep 4 people alive in the most hostile environment humans have ever entered. The engineering challenge hasn't changed since 1968. You need air, water, food, heat control, radiation protection, a way to slow down, and a way to survive landing. Technology has made every system lighter, faster, stronger, and more reliable, but it hasn't made any of it easy.
The Artemis 2 splashed down in the Pacific Ocean on April 11th. Recovery ships were all ready. If the capsule lands on its side or even upside down, airbags will inflate to flip it upright, a safety feature Apollo didn't have. Divers will swim out to the bobbing spacecraft, open the hatch, and guide the 4 astronauts into the sunlight. These 4 will be the first humans to travel beyond Earth orbit in more than 50 years. They won't just be returning, they'll be trailblazers. Every system they've tested, the life support, navigation, heat shield, communications, exercise gear, even the toilet, will shape how future crews go to the moon and beyond. They'll see things that change the way we understand our planet, our place in the universe, and the incredible luck of living on the one rock in the solar system with breathable air. When Apollo astronauts came home, they returned as conquerors of the moon. Artemis 2 will return as pathfinders. The moon is no longer the final destination. It's the first stop on a journey that will one day take humans to Mars. Orion has already been tested for missions lasting up to 1,000 days when paired with additional modules. Artemis 2 crew is collecting vital data: how their bodies handle deep space radiation, how they sleep, how their hearts and circulatory systems respond. Every piece of this information will shape the first human journey to another planet. Apollo proved we could leave Earth. Artemis is figuring out how to stay gone. Today, 4 humans are closer to the moon than anyone has been since 1972. They're looking out of windows bigger and clearer than anything Apollo had. They're sending images home at speeds that make Apollo's radios seem like smoke signals, flying a spacecraft that can almost think for itself, powered by the sun and built from decades of lessons learned, failures endured, and money and time invested. They aren't repeating Apollo, they're picking up the story where it left off, weaving something entirely new. This is exploration at its purest, bold, human, and alive. And now, it's your turn to follow the journey. Stay connected, witness history in the making, and be inspired by what humanity can achieve. Subscribe, share, and join us as we watch Artemis 2 pave the way to the stars.